Okay, welcome back. We're still on chapter 2, and the next section is going to be fire, which is another way of taking in arguments for a script on the command line. The other two ways, the first way is just using argv. That's the way I still use. It's quick, it's easy, it's simple. Definitely a better way to do it though is something called argparse. Then you get a help menu. You get things done for you to make it look all nice and pretty and standardized. A lot of my scripts are kind of done in my own interest, so I'm really happy to hear about. I have used argparse before, but the one I'm really happy to have learned about is what was called click that we learned about last time. It's basically like argparse, where it's got a help menu for you. It's got things already coded out, ready for you to just call in the code and make it easy on you. But it does it as a decorator. So when you design how you want your code written, you can include the arguments that you're going to take into your script. You can include the code for that in with where you define the function that you want those arguments to apply to. So you can kind of organize your script in a different way by using decorators and the click method. Another way is the fire module, and that's what we're going to learn about now, fire. Now let's take a step farther down the road of making a command line tool with minimal UI code. The fire package uses introspection of your code to create interfaces automatically. If you have a simple function you want to expose, you call fire. Fire with it as an argument. You call fire.fire. So fire is the name of the library that you import. You do import fire, so you've got to call that out. And then .fire is a class within that library. So that's what this here is. You call fire.fire with it as an argument. So the thing you're going to have as an argument is the function that you want UI input for. So let's go ahead and type this out here. So I've got my terminal here. We'll change directory to my project, and then we'll activate the virtual environment. Okay, and now if I do IPython and I do import fire, I don't have a module named fire. This is not part of the standard Python library. Argparse is part of the standard library, as is argv parsing, because that's just part of the sys module, which is standard library. So once you start using click and fire, you've got to make sure that you've got a public internet connection from your device where you're doing your scripting from. And in some cases, you might need sudo access elevated privileges to install modules. I think if you have your virtual environment open though, since it's just in that custom environment that gets blown away at the end, you might not need admin privileges to install a module where you would have needed it before. So always have a virtual environment created and running. I've just now I'm realizing just how valuable that is. I've kind of had an attitude of it in the past that, oh, okay, you can have it, you cannot have it, what's the big deal? But nowadays it's like, now that I'm comfortable using them, like before, I wasn't incredibly comfortable using them, and sometimes I was still using Python 2 a bit, which didn't have them in there by default. Python 3 makes it a lot easier to use them. So I was like, you cannot use them sometimes. But now with Python 3 being, 3.8, the established thing out there, with Vmv being included in it, super easy to use, super easy to learn. Always use a Vmv. There's no reason not to, and it'll make your life so much easier. So I'm a little bit disappointed that this book didn't go over that. Maybe it will later on, but for me, that's Python 101. The first thing you should learn nowadays when you're learning Python is to set up the VNV, why you need it, what it's for, because then you keep your computer nice and clean that way, and otherwise you mess things up, things go all messy, and things don't work the way you expected to. It's much better to have a virtual environment running. Okay, so let's do this example here. So we're going to open up Visual Studio and type this out in there. So the name of the file here that they want, I think it's simplefire.py is going to be the name. Yeah, simplefire.py. So we'll do that. Simplefire.py. Okay, so now I've got Visual Studio open. I would like to just have this open in my terminal. Oh, I don't have a. Okay, well, I think when I save it in the terminal here, it will save. So we'll do the whole thing they have here be a typing exercise, basically, at the beginning. Something's happened. Okay, there we go. Lagged on me. Okay, so now we can import Fire since we have that. Let me try this. Let me try saving this. Okay, and now let me try to reveal in. Let's just copy the path and then go down here and do CD. Okay, and now, oops, it's not. It's not. Of course, it's not a directory. Okay, well, I don't know why I can't open this for some reason. Oh, here we go. Open an integrated terminal. Perfect. Okay. Now I can start the bash in there, and then I don't need to it's not the bash. I can start the virtual environment. And now I've got a bash terminal, so bash uses the source. The other one was a PowerShell terminal. Maybe it was bin? Oh, it looks like they want me to use double here as well. Okay, perfect. I've got it. Yeah, they wanted double slashes there. That's fine. And then I've got the VMV working now, so that's all I needed. Why is my bash so messed up? I don't know why my bash terminal here is so bad, but it seems to not have a lot of really basic commands that are usually there. Okay, so let's see what Fire is going to do here. So we've got a function here that has some positional arguments here. These are not keyword arguments, they're positional arguments, but they have default values assigned to them. I think so, actually. I'm actually not sure about that. I'm going to do an experiment. One of the things I really like about Python is how easy it is to experiment. You just pull up into the terminal, and then if you thought the Python code worked a certain way, try it out and see if you were right and see if you were wrong. And if you were wrong, try to figure out why you were wrong and try to figure out how you can more predictably use it in the future. Oh, that's cool. Is this really what I think it's going to do? So it looks like we have a function here defined with that has two parameters. So it takes two arguments. The first argument so the first argument is going to be the greeting. The second argument is going to be the name. But it looks like since we used keywords here in our parameters, or we use this default parameter, Fire knows to build those into a UI automatically. So if we go Python simple fire help, yeah, since we have these here, and what is this? Show fixes, exact expression into function. What does that mean? Extract. Func. I don't understand why is all of this happening right now? I'm really confused. Okay, I don't know what's going on there. That's really confusing me. And that's another reason why I don't typically like using terminals, because, or I don't typically like using this because a lot of times you get things popping up that just are not welcome. But we can see it's simple what happened. Fire.fire took those two defined parameters, and they made a syntax for getting them from the user automatically, just because you have that installed. Okay. In simple cases, you can expose multiple methods automatically by invoking fire with no arguments. All right, let's try that. So here we've got the same thing we had before for the function, and then it looks like they build another function down here. Goodbye. And then okay, so it looks like now we can so Fire creates a command from each function and documents automatically. So we don't even need this greet because it's just so simple. What we're doing, Fire can figure it out without being lent a hand. There we go. And now we've got, ooh, I'm not sure it worked. Did it work? Oh, it needs to, okay, it's paginated now, so it's got multiple pages here. Yep, but we can see we've got the goodbye on there now. Yep. This is really convenient if you are trying to understand someone else's code or debug your own. With one line of additional code, you can interact with all of a module's function functions from the command line. That is powerful because Fire uses the structure of your program itself to determine the interface. It is even more tied to your non-interface code than argparse or click. To mimic our nest interface, command interface, you need to define classes with the structure of the interface you want to expose. To see an approach to this, check out example 3-6. Okay, so it's quite a bit different. We'll just do the whole thing. It's a lot of typing. I mean, a lot of the times lately I've been skipping it. Let's keep some of this stuff. No reason to retype it. I love this though. This is really good. Okay, so we've got. Okay, so now we've got new functions. Okay, so we know what this self means now. It's the instantiated class. So when we do, for example, ship equals ships, ship will be referring to the self, so we can do ship.sail because we've got that self in there. So you're passing the argument here, not in between parentheses, but with the name of the instantiated class and then a dot syntax. Okay, ship name your ship. Print ship name is setting sail. Okay, so there's our first method. We've also got an init method, but when we instantiate this class, we don't need to have it do anything special, so we're just going to go with the default init that it gets. So it's kind of like a function where there's a implicit return statement that returns none. Classes are the same. There's an implicit init statement that inits like an init class or something. It doesn't do anything basically. I think it's what makes it so that you can instantiate the class like the init method by default. I think. I honestly I don't know. I'm gonna move on. I just kind of was grasping at straws to figure it out because I thought that this book touched upon that. So I thought I could remember it from what I had read earlier in this book. There we go. Okay, so we're gonna have probably another method maybe. Let's see. Yep, so we got one more method and then looks like we even got one more class after that. Okay, so we got one more class. Okay, here we will have an init that is not the default init. Okay, so it looks like we get we instantiate the class here. I'm surprised that sailors is happening first. I would think that would need to happen second, but we'll see what happens. We'll try to run it. Okay, so we'll take this CLI class and we'll make a automatic user interface for it without having to do any special code ourselves. So let me hit the run and debug button and see if that works. Is that gonna work? It didn't work. Oh, I think it's going through line by line. Oh, okay. No module named Fire. Oh, what happened to my virtual environment? I don't know. My virtual environment. Oh, it didn't start up. Okay, well, so much for that idea. Okay, we'll just run it in here. Why don't I have... I'm so confused. I don't understand. I mean, it doesn't seem like it's a bash shell. Is that really what a bash shell is? Let's try a git bash shell. Or let's try a PowerShell. Yeah. Okay. That'll work. Oh, I didn't move into my project. Okay, there we go. Yeah, this is a much better terminal. So now I can do a dir. Perfect, I can see all my files now. Okay, so Python, and then this is Simple Fire, I think it was. What was this called? Yeah, simplefire.py. Okay, so it says, hiya Tammy, but what we're interested in is this help menu. There we go. So we've got how do you want to greet, who do you want to greet, show this message and exit. So, wow, okay. That's cool. How did it know to say how do you want to and who do you want to? Because I didn't put that anywhere in the code. Wow, that's cool. Yeah, that's not anywhere in the code. Okay, well, I'm going to be using Fire. I'll tell you that. Whenever I need to take user input, I'm going to be using Fire. Okay, so let's read the step-by-step rundown of what we did. So the first thing we did is defined a class for the ships commands. We did that right here. The sailors has no subcommands, so it can be defined as a function. Okay. Define a class to act as the top group. Add the sailors function to the ships as attributes of the class. Oh, did they want this to be unindented? See, this is I wish they had I wish this were better, this Amazon Kindle book, because I can't tell if it's unindented or not. But I get the same results. Oh, it's kind of cold. Or it's kind of dark. There we go. Okay, define a class to act as the top group, add the sailors function and the ships as attributes of the class. And the last step is call fire.fire, which we did down here, on the class acting as the top level group, as that one. Oh, you know what? They actually didn't want this to be a part of the class. And you know how I know that for sure? There's no self included here. I mean, greeting could take the place of self. Like, it doesn't have to be called self, but if they wanted it to be a part of the class, I'm sure this book had good enough Python habits to have self there. So I know for a fact that this is not meant to be a part of the class. Okay, the automatically generated documentation at the top level represents the ship's class as a group and the sailor's command as a command. Oh, okay. So now we get, so let's see if we got the same thing. So if we do, what was it, fire example? No, it's simple fire is the name of this. Oh, I ran simple click instead. So simple fire.py. Okay, perfect. Now I wonder if this wouldn't have run when I had it incorrect like that. Let's try it, because I was running the wrong file, so I thought it. Yeah, see, okay, sailors is not defined because it's a part of the class. You don't have access to it until you instantiate the class. So you got to take it out of the class if you want to call it here before you instantiate the class. And we know that that is what the book intended because there's no self like there is for the other ones. How is this? I've had
Error 6. Move Roomba to a new location. Then press clean to restart.
I've had a Roomba like unplugged for like days and it's not running out of batteries, but when I actually use it, it runs out of batteries in like 2 seconds. When it wants to tell me annoying things that I already know, it has plenty of battery power, but it wants to actually clean the carpet, it doesn't have enough battery power. Which I guess makes sense because they require different amounts of battery power, but I was not expecting to get those sorts of messages. Because the wheel's jammed and I don't know how to fix it. But let's go back and try to stay focused here. I'm losing focus really fast. I've got about a half an hour to go, so yeah, I've completely lost my focus. Oh, right. So we can't run this line if we have this as part of the class because we didn't instantiate the class. We're going to do that on the next line. But if it's its own function, we can certainly run it, and then the next thing we do is instantiate the class, and then we just have two different things. One of the things is going to be a group, so that's going to be the class, and then a command, which is just going to be the function. So now it's going to run because it's its own thing, and we're going to see that ships is the group, and sailors is the command, just like in the book, ships and sailors. All right, the documentation for the ships group shows the commands representing the methods attached to the ship's class. And it knows not to show the init method because that's a special method that it doesn't need to show. So yeah, and now we can actually use the user interface too, because we can see we can follow the instructions that it gives us here. So so let's first do what they have here. So ships and then help. Okay, so now we can follow the instructions. We can give it a command here. So yeah, so here's the synopsis of our instructions here. So we can do a command here. So let's do one of the following commands. Let's try the sail command. Okay, your ship is setting sail. There we go. Now let's try the list command. There we go, and those are the ships we've got ready to sail. So perfect. Let's get some help on this. Okay, so we don't get any help with that. But look at how perfect that is. I'm going to be using Fire for all my scripts from now on. Thank you, thank you, thank you, Fire. This book has paid for itself. Let's see here. So, yeah, okay. The documentation for the ships group shows the commands representing the methods attached to the ships class. Yep, we saw that. The parameters for the sailors function are turned into positional arguments. Okay, so let's look at the sailors next. Okay, so yep, now we can see we can do greeting and name. So it's a positional argument. The greeting, hello, and then my name. There we go. So there we go. Perfect. You can also use flags syntax for positional arguments. You can call the commands and subcommands as expected. Okay, so let's follow along with what they have. Oh, something happened there. Oh, it opened up a... Okay, I can't use that syntax. I have to use Python. There we go. Okay, your ship is setting sail. Perfect. Yeah, for me, it's unclear when you can and when you can't use this kind of... I think it's because my file isn't executable or something. I have no idea. Oh, because I don't have the shebang, right? No, I have the shebang. Okay, yeah, so I have no idea. Okay, so let's do the next example. So we'll do ships list. Oops, and we've got a problem here. Oh, there we go. Instead of sail, we're going to do list. There we go. Did that before. And then we'll do sailors. H-I, Carl. Oh. So you can see the ships, we don't have that. So ships wasn't the right word. Yeah, we have to get rid of ships if we want to do sailors. There we go. An exciting feature of Fire. Well, Fire to me is exciting without. What is this feature? Is the ability to enter an interactive mode easily. By using the / interactive flag, Fire opens an IPython shell, wow, with the object and functions of your script available. Holy cow. Wow. That is really good. Oh, it didn't do it. Why didn't it do it? Oh, I had a space. I had an extra space. Oh. Do there need to be 4 of these? I don't get why this isn't working. It didn't work. Could not consume arg. Is it in the help? Oh, perfect. Okay, so yeah, the syntax is really strange. I'll make it very clear what the syntax is. So you've got to have all of your required arguments, and then two dashes, and then a space, and then two more dashes, and then without a space, the word interactive. So really strange syntax there, but hey, it's a small price to pay for being able to do this. I mean, now I have, if I do a dir, I've got my, looks like my whole script is in here. But yeah, I've got all my variables defined, sailors, sailors function, result, component. Yeah, it's so perfect. Like this is a dream come true. I wish I knew about this earlier. Okay, so yep, and then it tells you the objects it starts with. It starts with the fire module, and then it starts with your class, your function, everything you need to get in there and explore. So this is what we did. We looked at sailors. Yep, and we can test out that function. Sailors. Test 1, test 2. Okay, and we can also get help on the function now. But sorry for that. But the help is only as good as the quality of your doc string. So we don't have one in there, so we're not going to get good help on that. Part of me wonders if the best thing to do for a docstring and help is to just put the actual code in the docstring, but then if you make a correction, you have to correct the docstring as well. But for me, like it's more, the most helpful thing you can show me is the code. Here we run the maritime programs sailors command in an interactive mode. An IPython shell opens and you have access to the sailors function. This interactive mode, in combination with the ease of exposing objects with fire, makes it the right tool both for debugging and introducing yourself to new code. You have now run the gamut in command line tool building libraries, from the very hands-on argparse to the less verbose click, and lastly to the minimal fire. So which one should you use? Fire. We recommend click, okay, for most use cases. It balances ease and control. In the case of complex interfaces where you want to separate the UI code from business logic, argparse is the way to go. Moreover, if you need to access code quickly that does not have a command line interface quickly, if you need to access code that does not have a command line interface quickly, Fire is right for you. All right, the next part is implementing plugins. Once you've implemented your application's command line user interface, you might want to consider a plugin system. Plugins are pieces of code supplied by the user of your program to extend functionality. Plugin systems are used in all sorts of applications, from large applications like Autodesk's Maya to minimal web frameworks like Flask. You could write a tool that handles walking a file system and allows a user to provide plugins to operate on its contents. A key part of any plugin system is plugin discover. Your program needs to know what plugins are available to load and run. In example 3-7, we write a simple application that discovers and runs plugins. It uses a user-supplied prefix to search for, load, and run plugins. So this is example 3-7. We'll make a new file for this. So we're going to close the terminal. We're going to do code. Simple plugins.py. Okay, we'll close this, and then we'll add the shebang. Even though it doesn't seem to work. All right, and then we'll type out the rest of the code. Okay, and let's read the synopsis as we're doing this. So, oh wait, actually no, it doesn't start until later. So we'll just type it all out and then read the breakdown of what we did. Okay, and I'm not sure if this for statement here belongs to the function or not. I'm thinking it does not. It's hard to tell though with this Kindle book. The formatting just does not persist and makes it hard. Okay, and again, I'm not sure what the indentation is. It's not clear about that in this book. Okay, so the first thing we did is the pkgutil.iter modules returns all modules available in the current sys.path. So second thing is check if the module uses our plugin prefix. Use import lib to import the module, saving it in a dict for later use, and call the run method to the plugin. So let's see if the code works. I don't think it will because I don't think I have all of these modules. Oh, I haven't saved it yet. There we go. Yeah, so it looks like plugin prefix is not defined. Okay, I'm not sure what that means. Yeah, plugin prefix is not defined. I'm not sure what they're trying to get at here. They're not calling this function anywhere too. Maybe this is meant to be a part of the function. Yeah, that's what's going on. So I know that this is meant to be part of the function because this plugin prefix isn't defined anywhere, but it's called here. So it's defined when you call the function. So therefore this part belongs to the function. There we go. And now we can see it works. So if you're a beginner, you're trying to read this book, you're not going to figure this out. I'm sorry. I'm definitely intermediate to advanced when it comes to Python, so I know that what the indentation of this is meant to be, even though I can't tell just by reading the book. Okay, so supplying plugins to example 3-7 is as simple as supplying modules whose names use a shared prefix and whose functionality is accessed using a method run. If you write two files using the prefix foo plugin with individual run methods, as we see here, you can discover and run them with our plugin application. Okay. So I'm going to take their word for it. You can easily extend this simple example to create plugin systems for your applications. Okay, so that sounds good to me. I'm going to need to stop the video here at 45 minutes. When I come back, we'll be looking at a case study, turbocharging Python with command line tools.